Hello everybody, I'm Naked and welcome to another episode of Code Cop, the series where we go over terrible advice given in places like LinkedIn, Twitter, or blog posts, and we try to learn from it and turn it into good advice. And in today's video, I have such an insane piece of advice. I just couldn't expect people would post that, or that people would upvote it and say, yeah, that's great. And it's on a topic that is so misunderstood. And this just adds fuel to the fire because it's on a wait async and asynchronous code. And especially when you're awaiting many things like this advice we're going to see, you can get things so wrong so easily. So let me just show you what I'm talking about. This is the advice. The problem, task.WaitAll. You have to synchronously wait for all the tasks. So you have a few tasks, you pass them down, it blocks until all tasks have been completed. Now, some people don't understand block, synchronous operation, asynchronous operation that has to wait for completion. There's many things that you can get wrong here. But the solution, the suggested solution, is task.WhenAny. So you still synchronously wait the tasks, but now you can get the completed index as they complete. And then from that completed index, as you can see in this code over here, which is horrible in every single way, you can allocate a new array for absolutely no reason, just because we have enough memory to waste, and then get the task, get the completed task, check if it's faulted, and then remove it from the list and keep WaitAnying. Okay. So there's a few things wrong here, including the reactions. Stop upvoting. This is LinkedIn. You just sneeze and anything with more than 5 likes goes to like the front page of .net world. That's the text that comes with the advice, which is a ChatGPT, honestly. This can't be written by a human. But I'm going to explain. You can just pause and read it. I'm not going to waste your time by explaining all this here. But like things like the solution is this. Faster response times. Why? Okay, yes, it's more responsive because you can keep processing them as they happen. But if the processing is in the method itself, WaitAll will do the exact same thing. It's not going to make a difference. What will make a difference is error handling. That's fair. Efficient resource usage, not really. It's not going to really make a difference. Better user experience. Okay, there's another page. You can pause and just take a look at it. I will explain everything when we take a look at the code, which I think we should. But this topic is so misunderstood. Like a wait async and tasks. Why would you make a post on this that is so wrong and confuse new people jumping into the world of .NET and asynchronous programming? It's just so bad. It's actually why we dedicated an entire 5-hour course on a wait async, which by the way, you can still use async 20 at checkout to get 20% off, link below. But if I take a look at the code, I have the exact same thing over here. And I have a delay milliseconds method that just awaits for some time. And then it tells you for how long you awaited. That's basically it. And then over here, I have 2 tasks. I put them in a list in the same way that this person had on that post. And then I do the same WaitAny insanity, including the 2 array allocation. Do you even need that? You need it because it accepts an array. Why wouldn't you have an array from the beginning then? Well, because then it's more complicated to remove a value from the array. Just bad code for the sake of posting something on LinkedIn. That's insane. Anyway, relax, Nick. So when you run this, yes, indeed, after 2 seconds, you're going to get something in the console. After 5 seconds, you're going to get something else in the console. The unfortunate thing is that as this is coded, because the index can change, because things can be removed, you can't really rely to the index to understand that, yeah, 0 is this, and then 1 is this, because this becomes 0 as the first one completes first and is removed. Bad examples, terrible examples. And I want to show you that here the wait async, because some of you might say, okay, why don't we just leave it to do a wait async internally and properly await it? Doesn't it do that? And the answer is here. So it's using some pretty advanced logic, but you can see here that this is using is sync blocking true. So this is synchronously blocking, as you can see over here. Actually, documentation doesn't say it. Yeah, the WhenAny is the asynchronous version and the WaitAny is the synchronous. Why? Just why? Now, there's many ways to deal with this problem in .NET. The easiest one is, if you want to have it asynchronously, is you can say task.WhenAny, and you can pass down the tasks, and this will spit back the task that completed first. So if you want to have this loop idea and have a when anything, then you can have that. So if I was to just run this as it is, what you'd expect is the first task to complete, and then that's it, because we don't do anything with the rest of the code. So that's one of the ways you can code logic and sense and sensibility into the code. But you can also say task.WhenAll and just await the task list asynchronously together. They will work on the same logic. The difference is now you'd have to move any logic you have here in the method itself, including exception handling. Actually, this type of approach needs special exception handling because of how aggregate exceptions can happen in this method and how you have to surface them. So it's a bit trickier. But actually, .NET has introduced a way to do this exact same thing way easier. And that is task.WhenEach. This is a method that was added a couple of versions ago in .NET, and it returns an async enumerable of tasks. You pass an array or a collection of tasks down, and then as the tasks complete, you can loop through them in a for each loop. So if I was to have this here, I would say this, and you can't just await it because it's async enumerable. So I would have to say await for each of all tasks in this. And you get the task and you can have the exact same code. So if I was to just take this code and put it here, so remove this monstrosity from the face of the earth, you can get the ID and you can get the exception as well if you want. So here we have an ID which will stay consistent and we don't need to remove anything. And we can even shorthand this to this. And this will be properly asynchronous and will allow your system to scale properly. If I run this now, it's going to do the exact same thing, but with none of the insane logic we had before. If you want to wait tasks in that fashion, that's what you should be using. Even if you're in WhenAll, I would argue there's a use case for this depending on your code. Because probably, yeah, if you don't return anything, it's fine to have WhenAll. But if you do need to return something and do something with that thing you returned as you process, you will save time if you have something like this. And your application will scale better. And that's the recommended approach you should go with. None of that. This is just insane. WaitAny, WaitAll. Don't use the wait methods. Use the when methods in task. Those are the right ones. But now on from you. What do you think about this? And are there any common misconceptions in the wait async programming that people should know about? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching. And as always, keep coding.